Hello students, how are you? Today we will start class 10th chapter number 6. Already taken 2 periods related to its basics. I told you types of triangle according to the angles, types of the triangle according to the sides, congruency rule. Now come on the topic of class 10th, similarity. Triangles actually name of the chapter. So first we will try to understand the difference between congruent and triangle, then we will take many examples. First we will try to understand what is similarity. So here in your book given, this is introduction. You are familiar with the triangles and many of their properties, you know. What's triangle? Having 3 sides, 3 angles. Sum of 3 angle is 180 degree. According to the side, 3 types of triangle. According to the angle, 3 sides of triangles. So you know these properties. All of these you know. All of these you know. From your earlier classes in class 9th, you have studied congruence of triangles. So congruency of triangle, I told you. Many method told this is axiom, which is axiom, SAS. Then I told you this in the form of theorem. Then this is the generalization of this. Then what? Triple S and then RHS. This already you know. And then I told you theorem angle opposite to the equal side of a triangle are equal. And then converse of it also. Angle are equal, then opposite side are also equal. Recall that 2 figures are said to be congruent if they have the same shape. You know congruency rules, same as it is. There is no difference. So saying if they have a same shape and same size. So what's using? Same shape, same size. In this chapter we will study about the figure which have the same shape but not necessarily the same size. So here we will read what type of figures having same shape but not their, it may or it may not their same size. But in congruency what you need? Same shape need and same size you need. Size you need. Understood? But we will read in this chapter that's what you need. Shape same need. Size may or may not same. So that type of figure is known as, that type of things is what's name? Similar. 2 figure having the same shape. So then giving definition, 2 figure having the same shape. Like this, if taking triangle, then taking triangle of same type, but not necessarily their same size are called similar figures. So try to understand the difference between congruence triangle and similar triangles. Congruence meaning same as it is. Their shape and size same. But in similarity, their shape is same, but size may be different. So this is the difference between congruence of triangle, congruency and similarity. So in particular, we shall discuss the similarity of triangles. So in this chapter, we will discuss what we will discuss. Similarity of triangles. It's meaning what type of triangle having the same shape but size may or may not same. So that's saying similarity. We will study in this chapter about what? Similarity of triangles and apply this knowledge giving a simple proof of Pythagoras theorems learned earlier. So about Pythagoras theorem, perpendicular square plus base square is equal to hypotenuse square. So, and apply this knowledge in giving a simple proof. So later on, we will give what we will give proof of what? Pythagoras theorem, which saying p square plus b square equal to h square. P perpendicular, b base, h hypotenuse. I know you know already one proof of Pythagoras theorem, but here after reading similarity rules, you are able to drive what? Easy method for the proof of the Pythagoras theorem. Can you guess how height of mountain, say Mount Everest, or a distance of some long distant object, say moon, have been found out? So we are finding out the height of the Mount Everest, finding out the height of the moon. So directly possible? Not possible. These are finding out with the help of indirectly. Understood? Or we can say like this, taking the help of similarity rules. So taking the help of similarity rules. Do you think these have been measured directly with the help of measuring tape? Is this, you can think that directly we can measure the height of a mountain, we can directly measure the height of a moon? Not possible. In fact, all these heights and distance have been found out using the idea of indirect measurement that I told you. Directly their height not possible to measure. So the indirectly we have measured these with the help of some rules, we can say, and similarity rule also playing an important role too for finding the height of these type of you can say Taj Mahal, Mount Everest, you can say, moon, you can say, which is based on this principle of similarity of figure. Told these are the benefits. This all is based on what? Similarity. This all is based on the principle of similarity of the figure. So if anybody is saying what's the benefit in our daily life of similarity rule, then directly you can say we can measure the distance of like this Mount Everest, like this moon, so which we cannot measure directly. We can measure indirectly with the help of principle of similarity rules. Understood? Later on this question also given, giving now example. So saying in class 9th you have seen all the circle with the show. Radii. Radii is the plural form of radius. Understood? If two circle having same radius, this is one circle we have taken 3 centimeter, another circle we have taken this also 3 centimeter. So what we can say, both are congruent. Understood? Congruent meaning one impose on other, then it's completely covered it. So if you can put one on the other, it completely covered it, or other, in other word, how can you say it's congruence, meaning same shape and same size. Understood? So congruent, all square with the same side length are congruent. It's meaning you are taking square of same side meaning this, like this square you have taken. What you have taken of 4 centimeter, 3 centimeter. So this also 4 centimeter, this also 4 centimeter. So all are congruent. Understood? So we are taking rectangle also. If their size is same, shape is same. So if rectangle, talking about rectangle, definitely their shape are same. If size also same, size meaning their length and breadth also same, then we can say both are congruent. So now consider, say, any two circle. Are they congruent? These circle, if we can take this circle, this circle, this circle, this circle. So what you can say? Are they congruent? So we don't know are they congruent or not. We directly, you can say this circle is not congruent with this circle, but we don't know this and this are congruent or not. But if you can check, these also not congruent. Because like this, you can say its radius is 3 centimeter, its radius is 4 centimeter, and this radius is how much? 5 centimeter, and this 2.5 centimeter. So all are having different radius. So their shape are same, but their size is not same. So that's why written, now consider any two circles. Are they congruent? This circle taken and this circle we have taken, are they congruent? No. Why? Because their size is not same. Since all of them do not have the same radius, written here, they are not, if they are not same radius, it's meaning they are not congruent to each other. Not that some are congruent and some are not. So it may be possible some are congruent. When congruent? If their radii are same, radius are same. Understood? If radius are different, definitely they are not congruent. If radius same, then definitely they are congruent. Some of are congruent, some are not, but all of them have the same shape. But what you can measure? Shape same. Shape what same? Same. Or different? No. All are circle. All are circle. So written have the same shape. So they all are what we call similar. So this is the definition of similarity. If same shape but not same size. So what we can say? All these circle, this circle and this circle, all are not congruent, but all are similar. Why? Because their shape is same. So they all are what we call similar. Two similar figure have the same shape. Written again definition. Two similar figure have what? Same shape, but not necessarily the same size. But not necessarily the same size. So what's definition? It's one condition must satisfy. What condition? Shape same, size may be different. And if shape and size both are same, then definitely they are similar. Understood? And if both shape and size similar, it's meaning congruent also. So what you can say, is there any relationship between congruency and similarity? Yes. All congruent figure are similar, but similar need not be a congruent. Understood? Therefore, all circle are similar. What about two square or two equilateral triangles? So all square also similar, but they are not congruent. What about equilateral triangle? Equilateral triangle may or may not be congruent, but definitely they are similar. If their shape and size they are same, it's meaning congruent. If shape and size are different, they are similar. So what we can say? Congruent meaning similar, similar meaning not congruent. Understood? All congruent figure are similar, but similar need not be a congruent. So square or two, this already told you this figure given. So I think you understand this. Then given this equilateral triangles, I already told you. So at least I can say these two are not congruent. Directly I can say. This is small size, this is bigger one size. But their shape are same. Shape meaning their shape is equilateral. Equilateral meaning having all three sides are equal. So they definitely they are similar. But we don't know they are congruent or not. They are become congruent if their length of their side become equal to each other. Understood? From the above we can say that all congruent figure are similar. That already I told you. All congruent figure are similar, but similar figure need not be congruent. Understood? Try to understand this very important concept. All congruent figure are similar figure, but similar figure are need not be a congruent figure. Similar figure become congruent figure only when their size also become equal as their shape. So saying, can a circle and a square be similar? Think one time. A circle and a square are similar. Their shape is same. Circle is like this. And square is like this. So their shape also not same. Shape not same. If shape not same, definitely they are not similar. Understood? Can a triangle and a square be similar? Not. Their shape is not same. So they are not similar. Understood? The question can be answered by just looking at the figure. Evidently, these figures are not similar. Already told you. What's the reason here? Written why? So why you can say shape are not same. Shape also not same, meaning one is circle, one is square. Okay, and in second one what? One is triangle, one is square. So how can we shape? If shape not same, then how we can say these are similar? So these, look one time, this is a bigger photographer of Taj Mahal, this is smaller than this smaller than this. So what you can say? Shape same? Same or not? Same. Photo of Taj Mahal. But their size are different. So definitely they are not congruent. But they satisfying, what they satisfying? They satisfying the property of similarity. Similarity saying shape same, size may be different. Its size is less than this and its size is less than this. And this is a definition of similarity. If size is same, shape is same, size may or may not same. So given, what can you say about the two quadrilateral A, B, C, D and PQR? See figure, are they similar? In previous page given this. So this given, so look these. So are they similar? But we cannot be certain about it. So what you can say? Their shape is same. Shape is same. So it may or it may not be similar. We need more knowledge about these. We need knowledge about their side also. So 100% we cannot say these are similar or not. And if not similar, definitely not they are congruent. These figures appear to be similar, but we cannot be certain about it. Therefore, we must have some definition of similarity of figure. And based on these definitions, some rules decide whether the two given figures are similar or not. So, if anybody is saying what's the definition of similarity, you can say having same shape but not same size. This is, we can say 70% definition of a similarity. Similarity need more also, so that's telling rules to decide whether the two given figures are similar or not. For this, let us look at the photograph given in this figure. Figure given, its size is more than its size is more than its. So it's this size, then enlarge this size become, then enlarge this size become. So in this way, what? Both increasing, meaning length and breadth. This is the length, this is the breadth. Both are increasing, but they are increasing in the same ratio. Same ratio also. So you will at once say that these photographs of the same monuments, the Taj Mahal, but in different size. Would you say that these photographs are similar? Yes, they are. Why? Because same shape, whose Taj Mahal, and their side, it's meaning enlarge this photo, then this become. Enlarge this photo, then this become. So both, what's two-dimension length and breadth, both are increasing in the same ratio. Understood? So that's why we can say these are similar. So what you can say about the two photographs of the same size at the same person? If we are having a two photographs of same person, of the same person, same size at the year of 10 years and other is at the age of 40 years. Same photo like this, one photo is this in the age of 10 years, in the age of 40 years. So same shape? No. So much change in the shape. So not satisfying the first condition of similarity. So directly we can say these are not similar. So what you can say? Are these photographs similar? These photographs are of the same size, but certainly they are not having the same shape, so they are not similar. That I told you. And this is the symbol of similarity. What's the symbol of similarity? This is. And this is the symbol of congruent. If not congruent, cross it. Not similar, cross it. Got it? What does the photographer do when the prints photographer of different size from same? Using same negative. It's using same negative. Same negative using its meaning same shape. So size what may be? What may be size? Increasing size or decreasing size? Ratio remains same. You must have heard about the stamps. You know about these photographs: stamp size, passport size, postal card size. Postal card using daghaj photograph. She generally takes a photograph of small size in films, say of 35 mm in size, and then enlarge into a bigger size, 45 mm or 55 mm. Thus, we consider any line segment in the. So it's meaning first 35, then increase 45, then increase 55. So ratio remains same. Increasing ratio same. Thus, we consider any line segment in the smaller photograph, its corresponding line segment in the bigger photograph or lines will be in what ratio? So, this ratio 45 by 35, if size increase 55 by 35, so ratio of that line segment, this really means every line segment of the smaller photographer enlarge in the ratio, this ratio. Which ratio? 35 raised to 45. If first time 35, then increase in this, then increase this. So ratio remains same. Understood? It can also be said that every line segment of the bigger photographer is reduced, decrease in the ratio. If we have bigger photographer of 45 centimeter and we are reducing this in this 35, so then also ratio 45 by 35. It depends on no. Yes or no. Further, if you consider inclination between any pair of corresponding line segment in the two photographs of different size, you shall see that these inclination are always equal. This is the essence of the similarity of two figures and in a particular two polygon. So what's the result of it? That you can understand. So what we need. So now definition of similarity here change. Some more explanation. Two figures are said to be similar if they are having same shape and their size are in the same ratio. Their size are in the same ratio. One activity for you. This is an activity. So what type of activity? So saying two polygons of the same number of sides are similar. If their sides are similar, their corresponding angle are equal and their corresponding side are in the same ratio. So two polygons of same number of sides are similar if angle are same and their corresponding side are in the same ratio. So what's the definition of similarity now? This one is a third definition we can say. First we are saying same shape, size may be different. Second, what I can say, their shape same and side are in the same ratio. Third one what? If it is a polygon meaning side are in the same ratio and angle must be equal, then they become same shape. Meaning of these all three definition is same. Meaning of this all three definition is same. Note that same ratio in the corresponding side is referred to as the scale factor for the representative fraction for the polygon. You must have heard that a world map, global map, blueprints of the construction of the buildings. So small photo you can say. Understood? On the basis of that photo making bigger one. Small globe you taking, bigger global taking. So shape same. And if anything increase in the same ratio. Increase in the same ratio. So in order to understand the similarity of figure more clearly, let's perform a following activity. One activity is given to you. You can try to understand and easily able to understand what's the difference between congruence and similarity. Similar rule, sorry. So one activity given, from this you can understand what is similar triangles or similar figure you can say. Place a light bulb at a point of O. This is the point O. And here is hanging one bulb. Nowadays YouTube are using CFL, that type of, but this is bulb is there. These are the light. Place a light bulb at point O on the ceiling meaning roof, and directly below it a table, and directly below it, what you can take? A table. A table we can take. Here also coming light, so we can put here tables, so its figure becomes downside also. Not looking, I know each and everything. So I'm telling directly below this table in your classroom, let us cut a polygon, say a quadrilateral. We have taken a quadrilateral, this quadrilateral I have taken. This we have taken. This. This quadrilateral. What's its name? A, B, C, D. Light fall on it and making its image. Making its image where? Here. This. This is A dash, this is B dash, this is C dash, this is D dash. Image you know. So what's written directly below a table in your classroom? Let us cut a polygon, say quadrilateral ABCD, form a plain cardboard and place this cardboard parallel to the ground between the light and bulb. So on the ceiling is a bulb and this is in parallel in this way, if it is a quadrilateral. So I can take like this. This is a quadrilateral. Understood? So its image being on, image where? On the ground. On the ground, not looking, but here looking. So what's saying? And the table, then the shadow ABCD. Cast the table, marks the outline point, shadow A dash, B dash, C dash, I told you. So figure become or not? Note that quadrilateral ABCD, this quadrilateral A dash, B dash, C dash, D dash is what? Enlarge. Enlarge meaning size increase as compared to quadrilateral. Which quadrilateral? ABCD. This is because of the property of light. This is a property of light. Propagates in a straight line. So you may also note that A lies on ray. So one ray is coming. What's coming? One ray is coming. Which ray is coming? This ray is one coming like this. This ray is coming. This is OA. Where gone? OA dash. Similarly, OB dash. OC dash. OD, O dash. Note that the same ratio in the corresponding side referred to as the scale factor. You must have heard that world map, global map and the blueprints for the construction of the building. And after this activity, if you can find out this, what's AB by A dash B dash, then what's BC by B dash C dash by CD by C dash D dash is equal by DA by D dash E dash. If you can measure these, all are in the same ratio. Its meaning, what's its meaning? Its meaning is this. AB by A dash B dash equal to what? BC by B dash C dash by what? CD by C dash D dash equal to what? BA by D dash E dash. Definitely they are equal. Understood? So cast shadow this, then coming on the next page. So what's saying? So quadrilateral A dash, B dash, C dash is similar. So it's meaning angle are same, and side are in the same ratio. Side are in the same ratio. Side are in the same ratio. Where? Look one time. These are the side in the same ratio. Angle same, same figure. Enlargement of that figure. So angle remains same. So what we can say, how can we prove two triangle are similar? Till here we can say, if we can prove angle are same, and size are in the corresponding side are in the same ratio, then what we can say, two figure are similar. Got it? So written here, you can also note that vertex A dash correspondence must need. That's we are using in that CPCT corresponding part of the congruent triangle. Here also correspondence needs. Without correspondence, not possible. We can say like this figure A, B, C, D is similar to A dash, B dash, C dash, D dash. It's meaning A correspondence, A dash, B correspondence, B dash, C correspondence, C dash, D correspondence, D dash. Understood or not? So we can write like this: A, B, C, D is similar to quadrilateral. We can say quadrilateral. We can say B dash, C dash, D dash, E dash. Not 100% wrong. Corresponding must need. Without correspondence, you can not prove. So here written correspondence this A dash, B dash, C dash, D dash. By actually measuring the angles and the side of the two quadrilateral, you may verify that. What you verify? Both are similar. Both are similar. So given one example given. So what? Look one time. First is this. Already I told. Angle are equal. These angle are equal. These angle are equal. These corresponding angle are equal, and corresponding side are in the same ratio. This is you can say another definition of similar triangles, similar figure, sorry. And side are in the same ratio. So this again means that the two polygons of the same number of sides are similar. Two polygons of the same number of sides are similar if their angles, corresponding angle are equal and corresponding side are in the same ratio. If not using correspondence, we cannot say they are similar or not. But if their corresponding side ratio are same, corresponding angle are equal, then 100% we can say they are similar. So written, all the corresponding angle are equal using what? Corresponding. All the corresponding side are in the same ratio, proportion. Understood? From the above, you can easily see that quadrilateral ABCD and PQR figure are similar. So this figure given, which figure given? AB, CD, PQ, RS. So angle, look one time. Angle A equal to angle P, both are of 105 degree. Look one time. Angle B equal to angle Q. What's 100 degree? Yes, angle C equal to angle R, each equal to 70 degree. Angle D equal to angle S, how much? 85 degree. It's meaning angle are equal. It's meaning satisfying first property. Now you can check its sides. AB by PQ. AB 1.5 centimeter by 3. If you can show it's 1 by 2 coming. Then what? BC this 2.5 by QR. 2.5 by what? 5 is this. How much? 1 by 2. Similarly, if you can check CD by RS. CD how much? 2.4. That's what? 4.8. Again what? 1 by 2. If you can check this and this also same ratio. It's meaning ratio of the corresponding side are also same. Corresponding angle also equal. So it's meaning definitely they are similar. But actual this is the not way of the writing angle. Angle A written. Angle A, one angle is this, another is this. So which one is the best way of writing? You can write angle DAB. Then we can say we are talking about this angle. This is wrong way of writing, but sometimes we can write because we are talking about quadrilateral, it's meaning talking about the interior angle of the quadrilateral. But exact way of writing is this. If we have to write this angle, so we have to start from this angle SPQ. Q. Then we can say this is equal to 105 degree. If written angle P, so angle P I have written 105 degree. Another one written angle P equal to how much? 255 degree. This also right, because total sum is 360 and not told talking about interior angle of this quadrilateral or exterior angle of this quadrilateral. That's why we are saying right like this S P Q, then definitely this is 105 degree. So try to understand this also. This is also important. Sometime it may be possible examiner thinking is okay, no problem. But sometime it may be possible cross it. I don't understand he or she talking about which angle. So remark, you can verify that if one polygon is similar to another polygon, this second polygon is similar to third polygon. So saying like this is a square is similar to this square. This is ABCD, this is PQRS, and this is square is PQRS is similar to another square EFGH. So then these two also similar. So square ABCD is also similar to square EFGH. This is the meaning of this remarks. First is similar to second and second is similar to third. It's meaning first similar to third also. Got it? You may note that the two quadrilateral, that is a square and rectangle of corresponding. So you are taking an example. What's example? One is the square and one is the rectangle. We know each angle of square is also 90 degree, each angle of a rectangle also 90 degree. It's meaning what? Corresponding angle are equal. Its meaning is this. Corresponding angles are equal, but their corresponding side are not in the same ratio. So corresponding side are not in the same ratio. Why? Because square whose all sides are equal, rectangle whose length and breadth are different. Understood? Opposite side are equal, but all sides are not equal. A rectangle become a square when its all side become equal. That's why saying all square are rectangle, but all rectangle are not square. So two quadrilateral are not similar. Similarly, you may note that the two quadrilateral is square and a rhombus. What's the difference between square and rhombus? First try to understand this. So square having all sides are equal, each angle is equal to 90 degree. What's the rhombus? It's meaning if all sides are equal, but it's not necessary each angle is equal to 90 degree. So it's meaning side are in the same ratio. Side of the square, side of the rhombus are equal. It means side are in the same ratio, but their angle are not same. So what we can say? Satisfying one condition of similarity, but not satisfying the another condition of similarity. So it's meaning they are not similar. So what we can say? One thing, try to understand all square are rhombus, but all rhombus are not a square. Rhombus become a square only when if its each angle is become equal to 90 degree, or we can say one angle become 90 degree. Alternately, if one angle become remaining also become 90 degree. This is also a theorem. Later on we can prove it. So thus either of the above two condition, first condition, corresponding angle are equal, corresponding side are in the same ratio. If any one condition not satisfied by the two figure, it's meaning not similar. So if they are similar, definitely satisfying the both the condition number 1 and condition number 2. Understood? Thus either of the above two conditions, first and second, of similarity of two polygons is not sufficient for them to be similar. So what's coming? This exercise came now. What's coming? Exercise coming. So try to understand. Saying all circle are congruent or similar? Similar. Because their shape are same. size may be different. So all circle are similar. All square are congruent. All square meaning shape is same, size may be different. One square of size 3 centimeter, another square of size 4 centimeter. Both are square, but both are not same. Sorry, side are not in the same. So what we can say? Again we can say all square are similar. Congruent meaning same as it is, but satisfying the condition of similarity. What condition? How can? Square we have taken one square, this we have taken this 3 centimeter, 3 centimeter, 3 centimeter, 3 centimeter. Another square we have taken 4 centimeter, 4 centimeter, 4 centimeter. Its name is ABCD. Its name is EFGH. Angle, you know, if it is talking about the square, and each angle is equal to 90 degrees. So corresponding angle are equal. So what about corresponding sides? AD by EH, 3 by 4. Side ratio are also same. So they are not congruent, but they are similar. All triangle are similar. What type of triangle? Equilateral triangles. Its all sides are equal and each angle is equal to 60 degree. One triangle we are taking like this. 3 centimeter, 3 centimeter, 3 centimeter. A, B, C. Another triangle we have taken like this. E, F, G. It's 5 centimeter, 5 centimeter, 5 centimeter. Angle 60, this also 60. This 60, this also 60. This 60, this also. You know about this. So corresponding angle are equal, corresponding side also in the same ratio. But in isosceles we cannot see. About third side we don't know. So, understood? Which is your answer? This is your answer. We are talking about exercise 6.1. So two polygons of the same number of sides are similar. Two polygons of same number of sides. Sides are same. They are similar if and only if their corresponding angle are equal and their corresponding side are in the same ratio. Same ratio. Equal already this is. If they are equal, definitely they are in the same ratio. So what's coming? Proportional. This word coming. Their corresponding side are in the same ratio. For this you can use word proportional. So I told you about this. So this is simple exercise. You can solve it. Just want to tell you, try the difference between what? Difference between congruency rules and similarity rules. I already told you all the figures which are congruent, definitely they are similar, but similar figure need not be a congruent. Like this, you can take an example of a whiteboard. This board you can say digital board. If it is size, this size is, you can say 75 mm. Another digital board 65 mm. So both are similar, but both are not congruent. Congruent meaning same as it is in all respect. And similarity meaning shape same, size may be different. So give two different example pair of similar figures. So already I told you, we are talking about triangle. You can take this triangle. ABC, 3 centimeter, 3 centimeter, 3 centimeter. It's an equilateral triangle. Another one is what? Equilateral triangle DEF. DEF. Angle equal. This angle equal. This angle equal. This angle equal. This also equal. This is 5 centimeter. 5 centimeter. So angle A is equal to angle B. Angle B equal to angle E, angle C equal to angle F. It's meaning satisfying the first condition. Second condition, AB by DE 3 by 5, BC by EF is equal to 3 by 5, and AC by DF is equal to 3 by 5. So all are equal, it's meaning side are in the same ratio. Non-similar figure, so many example. You can write like this is a triangle and this square. Both are not similar because their shape are not same. About size, later on we can talk. First condition is their shape should be same. Understood? Like this in mathematics, we are using like term. What we can compare? We can compare like terms. Unlike term, we cannot compare. State whether the following quadrilateral are similar or not. So directly I can say, what I can say? This figure, this is a square. What is this? Square. This angle equal to this angle? Not. If we are tracking the similarity rule, it is P, Q, R, S, and quadrilateral, this also quadrilateral, and this is also quadrilateral, A, B, C, D. So angle are not equal. So this is the first condition. Corresponding angle must be equal. Corresponding side are in the same ratio. Corresponding side are in the same ratio. Corresponding side are in the same ratio here. Look one time, PQ by AB is equal to 1.5 by 3. It's meaning 1 by 2. Then we can take QR by BC. This is also 1.5 by 3. Again 1 by 2. And if we can take RS by what? CD. Again 1.5 by 3, again 1 by 2. And if we are taking SP equal to DA, this is also 1.5 by 3, 1 by 2. So what we can say? PQ by AB equal to QR by BC equal to RS by CD equal to SP by DA. So side are in the same ratio or not? Yes, satisfying second condition. What about first condition? This angle is not the 90 degree. Angle 90 degree become like this. But this is 90 degree. This is also 90 degree. This is also not 90 degree. Like this. So what we can say? These two quadrilateral are not similar. So this is all about similarity rules, not all about, we can say, till here we can say, this is the concept, basic, we can understand, try to understand the difference between congruency rule and similarity rules. So congruence meaning same as it is in all respects, same shape, same size. Similar meaning shape, same size may be different, may or may not different. If equal, then become congruent, if not equal, then similar. So all congruent figure are similar, but similar need not be a congruent. So one definition is this. Another definition is what? Corresponding side are in the same ratio. Corresponding angle are equal. Another definition, their shape, same, size, increase in definite ratio, same ratio, then also we can say. And last one, what saying? Two figures are said to be similar if their corresponding angle are equal and their corresponding side are in the same ratio. So in these two chapters, congruency rules and similarity, so much role of what? Correspondence. If you don't understand this correspondence, you are not able to understand the concept of similarity and congruence. So here correspondence must need. You can say ABCD is similar to EFGH if correspondence between these then you cannot say like this ABCD also congruent to FGHE. This is not 100% sure because correspondence may or may not, but here correspondence showing. So on the basis of this, you cannot say this. This try to understand. If you can understand this concept, able to solve this exercise. Otherwise, this chapter become difficult for you. According to me, chapter number which 6, 7 is also not so much difficult. So according to me, 1 or 2 chapter in 10th class, which are, we can say they are difficult. But if you can understand the concept, they are also not difficult. So we will try to solve this exercise examples one by one. First, I want to tell you can concentrate on theorems. Theorems are so much important, not coming in exam, but helpful in exam for solving the question. If you don't know theorem, not able to solve question. So you can, it's my suggestion, you can write all theorems of this chapter and paste on in your room and daily revise them and try to understand. So tomorrow we will start again new lectures. Thank you for today.